Hello, welcome to another video tutorial. Again, this is my humble self Cecile, and this is a video tutorial courtesy of Better Consulting. And like always, videos like this to come up to further our classes, to further our studies. So this is another continuation from previous topic we had last class on Saturday. So we are going to continue and try to wrap up this topic and be a little faster. So in today's session, we're going to look at the topic we have on our screen: modifying file and directory permissions using octal number. Okay, using octal numbers. Let's put an S right there. Okay, I mean, if from previous class we saw the owner, which is represented with a U, the group in the G, and the word or others represented with O. And we saw how we could use these, to change modify permissions, and using the show mode, the chon, modify permissions, assign permissions, and stuff like that. But now in this session, we're going to use octal numbers. Okay, so again, we know R, which is read permission, W write, X execute. So the R, this is standard. Okay, you have to know that this is standard. And read permission, octal is presented 4 as an octal number, the write 2, and execute 1. So if you add this up, it makes 7. Of my arithmetic is correct. Okay, so each of these categories can have whatever permissions assigned to them. So the owner, read write plus 4 plus 2 plus 1, 7, group, same thing, others, and that gives us 777. Okay, so understanding these, so once you see, it's not the back of your head that, okay, when you see R, that's 4, you see W, that's 2, you see X, that's 1. So you can have a scenario where it's just R dash X. So at the back of your mind, how many is that? Just know that's 4 plus 1, which is what? 5. Okay, these kind of permissions, yeah, you never know, you could see it. Okay, or R dash, and what's that? Just 4, dash. So that user, that file, whatever in this level has just 4. Okay, so keep in mind, we're changing using the letters read, write, execute with the figures. So let this not get you confused, but add to the knowledge we've had from previous class. So let's proceed. So for example, let's say assign full permission to a file called test. So how do we do this? We're going to assign full permission to a file called test, right? This means we'll use, what command are we going to use? The change mode command, right? We'll change it to the show mode, 777. Of assign permission to that file. Let's go to our server and do that so that we see what we are talking about. I'm going to bring my server right in. I'm going to bring up my server. Here's my server, my CentOS server. So let's say, for example, I'm going to create a file. Okay, I'm going to create a file called test. Create a file, right? Okay, let's ls l test. See, I did ls l test. So it has what? The R and the W, right? So what's that? 4 plus 2, that's 6. 644. That's the file permission it has right now. 644. Look at it right here. 644. Okay. Owner group world. I'm taking it slow so that you get the flow. So the current permission for that file is 644. Soon we're going to see 644. We're going to see the 644. We're going to see the four file permissions and default permission for directories and default permission for file and directories. Okay. So that question requires to change the permission of test to 777. So how do we do that? We do our show mode and do 777 and what test file. And enter. That permission has been assigned. Let us verify. ls-l test. You see, so I've given the test file full permission. All of the different categories have full permission. They can all rewrite, they can execute, they can all rewrite and execute. See? Makes sense. Cool. Let's say we want to remove some of that permission. Show mode. I could do show mode 6 4 2 for example. Test. Hit enter. I've changed the permission. Right? Let's verify. ls-l what test file. Boom, there we go. 642. Right, I gave others only what? Right permission. Ain't that amazing? It's easy as that. Okay, so let's keep going. So I'm going to make notes quite as we proceed so that, you know, if you need to come back to it, you can do that. So let's say we have a task to, let's say, use Octal numbers to assign the following permission to my file. Okay, so this is the name of the file called my file. To the file, my file. To the file, my file. Okay. Just send the following permission to the file, my file. So this is the permission we're going to assign. W read write execute read write read only dash. So use Octal numbers. So this is what, or what is this? 7 what 6 4, right? Am I right? Yeah, I'm so right. So which means to answer that question, we're going to do show mode 764 and the file called my file. That's how we're going to do it in our server. Okay, pause the video, go into your server and do this when you get to this point. Alright, then if this file, my file, doesn't exist in your system, then you have to create the file. You use the touch command, create the file. When you create the file, it's not going to have this permission by default. It's going to have something different. So you verify what the current permission is after creating the file. You should know how to do that by now. I just did it in the example in the server. And then you now come and apply these new permissions we are applying to the file. You show mode 6764. Right. Okay, another exercise says remove read from the word category only using Octal numbers. Right, how do we do that? How do we say remove read from the word category only? Again, this is owner, group, word, or others. And the question says remove word. Read. The R, read of the file. This same file. Right. Okay, to remove read from the category, we look at the owner using octal numbers. From the same form. Let me put the name of the file that I will know from the file. So we know the file we're talking about, that same file. So right now this is current. So now we have to remove it. How do we do it? Using octal numbers. Show mode again. Right? Show mode is gonna be 760 my file. Am I right? That should be right. Which means when we take out the ray category, everything is gonna be dash, triple dash. See, the rest stays the same. Let's go into our server and do this particular exercise so that we see. So in my server, do I have any file called my file? Let me verify. So I can ls. You know what? Let me just grab. Let's see if this is gonna work. Grab my file. I'm gonna search in the root directory a file called my file. Okay, it is searching. So that takes a while because the entire root directory, which I gave that command. I'm going to interrupt that. Okay, ls special. Then if I call my file, oh, I already have a file called my file right there. My server. Oh, and it has different permissions. Awesome. Okay, so I'm going to change the permission to the second exercise, and then do the third. You see, so this is a good scenario right there. Nice. So if you don't have the file called my file, go ahead and create it. So, but I have it in my server with the permission of what? What's this? 4, 2, that's 6, 6, 6, 666. Ooh, 666. Anyway, okay, 666 actually the default permission for files, and 777 is the default permission for directories. And we'll get to that one looking at UMass. Let's go ahead. Alright, so let me do the second scenario. If I do the third, so show mode 764 my file. The file has been created as the file permission has been changed for ls-l my file. Boom, there you go. Wow, you see that? See that? Let me do the last one. Show mode 760 my file. Ooh. ls-l my file. Interesting. This is amazing. File permission has been changed. So to an extent, there's some security measures. Once the permission to others is removed, they can't do anything, with that file. They can access the file, they can read the file, they can write on the file, they can execute the file. Yeah. So this is how we deny giving permissions to certain users or categories in the server. Okay, for files and directories. It could be a directory that has sensitive information or security information. Say the HRO department has a directory or folder with, with employee W2 stuff like that. They're only gonna be the HRO person or certain people access to whatever directory has such files. And such directories have limited file permissions. Okay, so there we go. There it is. So that's been done. Let's proceed. Okay, let's do something a little interesting. Let's spice it up a little bit. Okay, so let's say assign full permission to file and subdirectories all at the same time, right? Yeah, let's do that. Assign full permission to the T1 file, and it's sub directories all at once. Yep, let's do that all at once. Wow. Okay, do you know what that means? So first of all, so this is the file. I'll create my file. So this is the file T1, with subdirectories being this T1, put it this way, subdirectories being T2, T3, right, and T4. Which means, so this is the direct structure. So this is T1, subdirectory T2, T3, T4. You keep going down like that, each in inside the other. So now we want to assign full permission to just T1 alongside, not just to T1 alongside all these other directories. Okay, and do it, but all at once, not going one after the other, let's do it all at once. How do we do that? Okay, nice. So solution to this, first of all, we have to create our directory, right? Of course we have to create our directory. Those are directories. So that's the directory we're working on. So what's the command to create directory? mkdir. So the mkdir, how do we create a directory, all the rest inside each other in that tree order or structure? So we do our P, remember? Our P again, our uppercase P. And then I do my T1 slash T2 slash T3 slash T4. So that's what it's gonna be. Okay. And then we do our show mode now. Ch mode. Show mode. Now, next, remember, we once spoke about this in one of the early classes. Dash uppercase R. What does that stand for? Recursive. Recursive, which means recursive show mode. So we do our recursive uppercase R. I want the question to assign full permission, which means it is 777. Okay, and we'll do only on T1 only, and it's going to apply to the rest of the other directories down the structure. Okay, so that's how we do this. Again, so the arrow, this is doing it. Let me put this in the notes. Make a little something here. So this means arrow means doing a recursive, recursive show mode, and it goes and it applies. That's what I need. Down to all the directories. Right, so that's what it is. So let's come to our server. Let's do that. Let's do the exercise right away. So mkdir uppercase P, or T1 slash T2 slash T3 slash T4. Ooh, or it's lowercase P. Yeah, this has to be lowercase p, I think. Enter. Wow, let me do that correction in the notes here. I thought about that. This lowercase p is the R is uppercase. Okay, cool. So we made our directory. Do you want to check if it's there? I just do ls. You see, it shows me only T1. The rest are inside. You know, T2 is in T1. Let's do that. ls that's L T1. Oh, okay. Now you see T2 right there. With the structure. Directory. You see, you have different directory structures. I mean, 5 permissions. 4, that's 7. What? 3, 1. No. Oh, you have to read and execute. So that's 7, 5, 1. Okay. Now, we have created a directory. So let's do the second part. Show mode, uppercase R for recursive, permission, simple 7, what? T1 on, right? Yeah. Hit enter. Let's see that if it changed. That's L T1. Wow, all have full permission. T2 got full permission right there. You see? LS. Wow. Ain't that amazing? Okay, so let's look at something. So that's show mode. Oh, if I do T2, okay, well, I gotta go down inside to see. Anyway. Alright. So let's do recursive churn real quick, okay? Yeah, recursive churn, which means churn dash R. Okay. So let's say, for example, churn dash R JPEG. Remember JPEG. JPEG T1. So what this does is we change the ownership of the parent and its subdirectories to students. So all those direct subdirectories are inside T1, right? We're going to change the ownership from root maybe to JPEG. That's what this does. Okay. Uppercase recursive churn. Let me put that in the notes. So say this will change the ownership of the file T1 and producer the parent file and its subdirectories and its subdirectories, change it to what you get. Yeah, you with me? Take note of that. Just take note of that. It's a real lot of little things to do. Same thing with change group. Change group. So to change groups, what actually looking at the recursive. Change group dash arrow. Let's say style T1, right? So if the group was was root, is going to change it to staff, and you do that with all the other directories inside that T1 directory. Down the structure is going to do it. So my notes is this will change the group membership of parent and its directories to staff. Okay. Alright, so just take note of that. That's what it is. Okay, so we will continue, and this time we're going to continue look at umask value. Right, let me write that. Umask value. Okay, so what's the umask value? Now, the umask value is a certain number, okay, that is assigned to the file, to a directory, and the system itself has a umask value. Okay, let's take note of that. So the umask value is also configured for every user profile at login by the site profile. In one of the class, we look at the site profile, we look at the user profile. So the umask value, you know, is configured for every user profile, okay, by the site profile. All right, let's take a few, one or two paragraph or lines, and then so the default file, wow, file permission. I'm taking of the default file permission, right? And then it's 644. Okay. Next, the default. What am I typing today? Default directory. Permission. And then it's what, 755. 755. That's default file permission and default directory permission. Once you create a file, it automatically assigns it 644. Create a directory, it assigns it 755. Now, why is that the case? It is so because of the umask value. Alright, so the default permission for a file, okay, or directory, right, is determined, take note of this, by the umask value, okay, umask value of the system. See? The default permission for a file or directory is determined by the umask value of the system. So whatever the umask value of the system is, it's based on that which generates the default value for file, being 604 value for directory. So if you change the umask value of your system, automatically, you know, in line with that, the default umask value for the file directory will change as well. Okay, so right, okay, so if we see display umask value of the system, and to do that, the command is just umask. Just type umask. Let's go to our server and do that. I'm going to clear my screen. We'll type umask. Boom. and then we see the UMax value of my system 22. Well, it could just be 022. Sometimes you put the first 0 in bracket, then 022, but automatically it's 22. Okay, so that's it. Well, that's how you check the UMax value of the system. Let me also add what I mentioned before. I said UMax value is configured, right, for every user profile, by the site profile, user profile, login, website profile. So we know the default UMax value of a file for UMax value of a directory, but the maximum, okay, maximum UMax file permission is 666. No. And maximum UMax for directory permission is 777. How do we? Okay, now we know that. Okay, those are like fundamental things to know. Okay, so now to get that default file permission, right, of 644, or the UMax value of 604, what we did was we took the maximum UMax file value and minus it from the system UMax value. You know what I mean? That means in order to get this default permission for a file, default file permission to be 644, we took the maximum UMax per file being 666, and we minus it from the system's UMax. The default system UMax value will be 222. Okay, that's what we did, and we got 604. Same thing with directory. We count the maximum directory UMax directory permission of 777 minus this 022, and we got 755. Keep that in mind. Fine. Yes, proceed. So if we have an exercise of, say, modify UMax value so that every file created will have the following permission. Have this permission: read, read write, read only, nothing. So this will modify the UMax value so that every file created will have the following permission. So every time you create a file, we want it to have that permission by default once you just create a file in the system. So if you do that by modifying the UMax value, see. So at this point, the UMax will be 026. Okay, it'll be 026. That's right. Alright, so our question says modify the UMax value so that every file created will have the following permission. What is this permission? Okay, let's first of all identify the numbers that make up this permission. That is 4 plus 2, which is what, 6. Okay, that's 6 right there. 4 0. So that's 640. Okay, so in order to get the UMax value that we need to modify in our system to enable every file created to have this permission, what do? We take this permission, the octal number that represents this permission that we're seeing, and we minus it from the maximum UMax file permission that we know is exists by default, which is 666. So if we say, let me bring on my calculator so that I'm not making stuff up, right? I'm not making anything up. There we go. So to do it, we're gonna say 640 from what? 666, right? And it's 26. So our UMax value is gonna be 026. That's what that value we're gonna assign to enable every file created to have this permission. Okay, to have this permission. So how do we get to this point? Let me put that in the notes. So to modify the UMax value so that every file created will have the following permission, the solution will be current, or not, so given permission minus default maximum UMax file permission. Okay, in our example it is 640, right? 640 from 666, which is equal to what? 026. See, so our system is going to have 126 is a new UMax value. So in order to answer that question, this is what we need to do. Get this UMax value, and then we go into our system and we put it in our system. And where do you put this in the system? Do you know? Where do you put this in the system? So we have this UMax value, right? But to do that now, we now have to go into certain file and put this UMax value so that each time a user logs in and create a file, it's going to give it this permission, because this UMax value has been permanently set up in our system. Okay, so I can just say, I can just go to my, let me bring up my server. Let me bring up my server. If I come to my server and I say UMax 026, so I've changed the UMax right now. Okay, keep in mind I've changed that UMax 026. So any file I touch, for example, touch that file. Okay, let's verify that file, right? ls that file, and that is the permission that it wants. We write arrow data dash 640, because we give our system this Umax of 0.26, but it doesn't end there. If I shut down the server and I restart it, it's going to go back to the default Umax. It will not keep this permanent. It will not apply this, and the question will not be answered in future files that will be created or directory. Why? Because this wasn't made permanent. To make it permanent, then we have to VI into a certain file, and at the bottom of that file we'll write this Umax value. Okay, right. So let's see if I can make up a note for you. So to make a Umax permanent, the solution, let's keep going the solution. A solution to that question, just type Umax and then 0.26. Okay, let me put this will apply the required file permission for any newly created file. Stop. But now that doesn't make it permanent, like we said. Okay, so to make the new Umax permanent, we VI into what file? Tell me. Now it is for a particular user account. If it's a particular user account, we have to VI into a certain file of the user account, right? So the VI into the .bash underscore profile of the user account. User account. See, and when we do that, and then at the bottom then of the file we add the Umax value we want. So which means this is what it's going to look like. Okay, it's a vi .bash underscore profile. You should remember this file, we saw it before. So when you vi .bash underscore profile, you scroll down to the bottom of the file, you just put your Umax thing 0.26 like that. Okay, don't remember if you have to put in quotes like this at the end, but try it. Okay, so let's go to our server and do it. So I've done the Umax 0.26, but like I said, it's not permanent. If I restart the server, it's not going to stay permanent. So to make it permanent, it's a vi. Let's see, hold on a minute. Who am I working with? I'm root. Okay, I'm root. This is best done in a regular user account. I don't want to do it in the root. Okay. Let's see. Let's fine. Let's see password. I'm going to go into JPAM's account and try to do it. So as you should notice, JPAM. Alright, I'm JPAM right now. Okay. Alright. Let's check JPAM. UMax is wow 0002. Now let me change it to 26. UMax 026. Change the UMax bar, type it again. UMax, that is the best, not permanent. The default UMax bar is just 0002, 002, and I do UMax to 026. I want to make it permanent to be 026. I have to VI into what? .bash underscore profile. So when I do that, I come at the bottom of the file, okay, and I do my what? UMask 026. Okay, I hope you see know your VI commands. And then I what? Save and quit. Now the UMask has been changed. So let's verify. I just type UMask. It's no more 0026, it's now 026. You see? Now I've made it permanent. When I restart the server, anytime I log back into the server, that's what when the JPAM logs in, that's the UMask that was gonna be there. So if I touch a file right now, say touch the file. The file. Okay, and then if I ls dash l the file, it has that permission because of this permission required because of the new UMask value. So I hope you followed. If not, please come back, watch the video, take your time, step by step, you know. Oh, and lastly, note that the above works for both file and directories. Okay, so that's it for UMask value. We're going to look at something in the next video, which is ACL. ACL means access control list. Okay, access control list. We're going to look at that in the next video. Thanks for watching. Hope you learned something. Please practice again. Practice makes perfect. AC access control is very interesting. We'll get into it. It's a continuation of this, a kind of a little deviation. Alright, take care and have a blessed day or evening or whatever time which you're watching this video. Bye.